encounter many mathematical phenomena in our learning phases, and they all are associated with some mathematical or fundamental properties to deal with it. Determinants are one such type. By learning various properties of determinants, we can simplify our calculations. More clearly, we can find the value of the determinants with minimum calculations. How? Let's find out. In this, we will be dealing with the determinants of order up to 3. The various properties of determinants are classified into interchange property, sign property, identical property, multiplication property, sum property, and the last is a property of invariance. Let's see one by one. First property, that is interchange property. It states that the value of the determinant remains unchanged if its rows and columns are interchanged. Let's see one example. Determinant 1, 2, 1, 2, 3, 4, 2, 1, 2. Now, if I take the transpose of this, I get A transpose, let this be A. A transpose is equal to determinant 1, 2, 2, 2, 3, 1, 1, 4, 2. Now, if we take the determinant of A and A transpose, we can see that determinant of A is equal to determinant of A transpose. When you calculate, you get the value as, the determinant value as 6. Alright? The next property is sign property. It states that if any two rows or columns of a determinant are interchanged, then the sign of the determinant changes. Let's see one example for better understanding. Determinant 1, 2, 1, 2, 3, 4, 2, 1, 2. Now this is our row 1, this is R2 and this is R3. Now if I interchange the row 1 and row 2, I get the determinant as 2, 3, 4, 1, 2, 1, 2, 1, 2. Now if we try to take the determinant of this and this, we can see that determinant of this matrix, let it be A, which will be equal to minus of determinant of this matrix, let it be B. Now what does the zero property states that? If any two rows or columns of a determinant are identical, then the value of a determinant is 0. Let's see one example. Determinant 2, 4, 5, 3, 2, 1, 2, 4, 5. If you closely observe, you can see that the row 1 and row 3, they are identical. So, we can directly write the determinant of this matrix will be equal to 0. Now, let's see the next property, that is multiplication property. If each element of a row or a column of a determinant is multiplied by a constant k, then what happens to the determinant? Then the value of the determinant also get multiplied by the same factor k. Let's see one example. Determinant 1, 2, 1, 2, 3, 4, 3, 6, 9. Now, if I multiply the row number 2 with some factor 2, the determinant will become determinant 1, 2, 1, second row multiplied with 2. So, 4, 6, 8, 3, 6, 9. If we take the determinant, we can see that determinant of matrix B, the determinant of matrix B will be equal to 2 times the determinant of matrix A. Also, you should note, if two rows or columns of a determinant maintains a linear or proportion relationship, then the determinant of that matrix will always be 0. For example, determinant 2, 1, 2, 3, 0, 1, 4, 2, 4. You can see here R1 and R3 maintains a proportion relationship. So, we can say that here the determinant will be 0. Now, let's talk about the sum property. If sum or all elements of a row or a column of a determinant are expressed as sum of two or more terms, then the determinant can be expressed as sum of two or more determinants. So, we'll see one example to get a better understanding of this property. Determinant A, B, C, second row A plus 2x, B plus 2y, C plus 2z, x, y, z. This can be written as determinant A, B, C, A, B, C, x, y, z plus determinant A, B, C, 2x, 2y, 2z, and the third row x, y, z. So, this can be expressed as sum of two or more terms. So, here A plus 2x, which is same as A plus 2x here. Alright. Now, coming to the last property, that is property of invariance. The property states that if the equimultiples of corresponding elements of other row or column are added to each element of any other row or column, then the value of the determinant remains same. That is, if I apply the operation Ri plus k into Rj to the row Ri, the value of the determinant remains the same. Similarly, to the column Ci plus k into Cj to the column number Ci, the value of the determinant remains the same. Let's see one example. Determinant x plus y, y plus z, and z plus x. In the second row, z, x, and y. Last row 1, 1, 1. So here you can see this is our R1, this is our R2, and this is our R3. Now if I apply R1 plus R2, I am adding it to R1. What will be the change now? The determinant x plus y plus z, x plus y plus z, and here also the change will be x plus y plus z. The second row there is no change, z, x, y, and the third row 1, 1, 1. Alright, now you can see that the first row and the third row, they have a proportion relationship. So, the determinant of this will become 0. With that, we have covered all properties of the determinants. Now, let's look at the ways of finding the inverse of a matrix using determinants in the coming video. Now, let's have a recap.
Manorama Horizon. Learning made simple.